with this polynomial equation. Okay, it's good. We'll know how to do that. Okay, so what this is saying is you're dividing this polynomial by this piece here. Okay, so you write it out as x minus 2 divided by 5x cubed plus 10x minus 13x squared minus 9. Okay, so the easiest way to do these is to check out this first value here. So what we're worried about is how we can change this x into a 5x cubed. So what would we need extra to make this x into a 5x cubed? Okay, well we need a 5, right? And then how many more x's do we need? Yeah, 2 more x's, okay? So that means x squared. So all you're doing is then you're going to go 5x squared times x, and you get 5x cubed. You have to, because that's the whole point of long division. If you don't get that, then you messed up somewhere. And then you go 5x squared times minus 2, which is negative 10x squared. Okay, right at this point, I can tell that I messed up somewhere.
Oh
No, it's not oh no, it's okay. Do you notice how this guy's an x and this guy's an x squared, but we have an x squared over here? What should I have done before I started?
Switch her out.
Yeah, I should have made them in ascending order. Okay, so I should have made sure that it was 5x cubed, then the x squared, then the x, and then the minus 9. Okay, so I'm just going to tweak that right here. Okay, so now we have it in descending order, and this is how we're going to do long division. So you subtract going down, right? So we have 5x cubed, subtract 5x cubed, you get 0. Okay? That's the point of this. If you don't get 0 there, then you made a mistake somewhere. Okay, now we're going minus 13x squared, subtract a negative 10x squared. Okay, so there is a double negative right here. Okay, so it's actually a minus 13 plus 10. So you'll get a minus 3x squared. Okay, because this we're subtracting down, so we're actually going minus 13 minus a minus 10. Okay. Okay, so then in long division, we always bring down a number and then we start again. So how can I make this x look like a negative 3x squared? What would I need? An x to a negative 3x squared. I need a negative 3 and an x, because when I multiply them, so this guy goes to him, this guy goes to him now. So I go minus 3x times x, and I get minus 3x squared. And then I go minus 3x times a minus 2, and I get a positive 6x. Okay, so again, we're subtracting. So a minus 3x squared minus a minus 3x squared is like minus 3x squared plus 3x squared. So this should be 0. And then we go 10, subtract 6. So that should be 4x. And we bring down our last guy, which is minus 9. Okay, and how can I make this x into a 4x? What would I have to do? I would need a 4. So I'll put a positive 4 there. And then this guy gets multiplied to the x, and this guy gets multiplied to the minus 2. So it's going to be 4x, and then 4 times a minus 2 is a minus 8. Okay, and we subtract. 4x minus 4x is 0, and a minus 9 minus a minus 8, so that's that's minus 9 plus 8 is a negative 1. Okay, so we ran out of numbers, we end up with a negative 1. So that is our remainder. So how we write this in the end is, this is what we got when we divided. So that is our answer. And then we have, okay, and then we have a remainder of minus 1 over what we were dividing, which was x minus 2. Okay, so this is what we got when we divided our 5x squared minus 3x plus 4, with a remainder of minus 1 over x minus 2. Okay, so looking at B for this example, it says identify any restrictions on the variable. So we were dividing by x minus 2. So what would be the restrictions for this? What cannot x can't equal what? 2, right? Because we don't want a 0 at the bottom. So if we add 2 over, we would say x cannot equal 2 for our restriction. Okay, and then C says write the corresponding statement that can be used to check the division. So if you wanted to check to make sure you were right, you would write it out as, I'm going to erase this here. Oh, I don't want to erase it because I don't know what we had for an answer. If we wanted to check, we would take our answer we got, and multiply it by what we had divided by. And then we need, what was our remainder? Oh, right there. Okay, and our remainder was what? Negative 1, so you gotta throw the negative 1 at the end. So if we were to like FOIL and multiply this all in, we would end up back with this original equation, if you did it right. Okay, that's what the question is saying. Okay, example 2, page 121. Volume of the nested boxes in the instruction in this section is cubic centimeters, is given by this. So they have the volume represented by that. What are the possible dimensions of the boxes in terms of x? If the height in centimeters is x plus 1. Okay, so say we have our box here. And we know the height is x plus 1, and we know the volume is this. We should be able to take the height, take the volume, divide by the height, and we should be able to get the other two side lengths. Okay, so we're just doing long division again. So we're going to go x cubed plus 7x squared plus 14x plus 8. And we're going to set this up into long division. Okay, so again, the same way what we did. We're going to go, how do we get this x to become an x cubed? You need it to multiply by x squared. So we're going to go x squared times x is x cubed, and x squared times 1 is 1x squared. We're going to subtract. We get 0 here. And 7 minus 1 is 6x squared. Bring down the positive 14x. Okay, now how do we make this x into a 6x squared? We need a positive 6 and an x. So 6x times x is 6x squared. 6x times 1 is a positive 6x. And we'll subtract. We get 0. 14 minus 6, or 14x minus 6x, we get 8x. Bring down the last 8. Okay, and then how do we make this x into an 8x? We need an 8. So we'll go 8 times 8x is 8x. And 8 times 1 is 8. When we subtract, we get 0. So that guy was a factor. And that means we ended up with an answer of this. Okay, so how could we find factors for this, what could you do?
What size of this as that?
Okay, yeah, we want to find common factors. So what multiplies to 8, what adds to 6, which are 4 and 2. So then we would write them as x plus 4 and x plus 2, because 4 plus 2 is 6 and 4 times 2 is 8. So these would be the possible dimensions of the cube. Okay, so an alternate to doing long division is synthetic division. So I'll show you how to do synthetic division. Okay, so we're going to take what makes this 0. So if it's x plus 3, we're actually talking about x is what then? Minus 3. Okay, so our minus 3 is going to hang out here. And this is how we do synthetic division. So it's important that you put your values, like your polynomial, in descending order so that it's all in order. So this one is power of 3, 2, 1, and power of none. So it's good. It's all in order. Okay? And another important thing for synthetic division is, say this equation went from 2x cubed to a minus 4x. So it went from 3 to 1 power. You have to put a placeholder in there. Okay? Like you would have to put a placeholder of 0x squared, just so that it goes 3, 2, 1. Okay? Because we can't have it jump spots. Okay, so what we're going to do, this one actually goes 3, 2, 1, 0, so we're okay. We don't need a placeholder this time. But if it skips, then you need to put a 0 in that spot. Because all we're going to do is we're going to take the numbers in front of the x's, okay? And the last guy doesn't have an x. So we're going to put them in for synthetic division. So we're writing 2, 3, a minus 4, and a 15, okay? No x's go in for synthetic division. We're just putting the numbers that were in front, okay? And that's why it's important you put a placeholder if necessary. Okay, so what we're going to do is we're going to bring down our first number, which is 2, and you multiply across, and then you add going down. Okay, so in the textbook, they always use the opposite number here. So if this was x plus 3, they put 3 in there, and they multiply this way and subtract going down, but you'll get the same thing. I've always just done it. You do the opposite number, so what your 0 would be, so minus 3. Multiply going across, add going down. Okay, so we're going to have minus 3 times 2 is a minus 6, and then we add straight down. So we go 3 plus a minus 2, a minus 6 is minus 3. Okay, and then you go minus 3 times minus 3 is a positive 9. And then you add down. So you go minus 4 plus 9 is a positive 5. And then you go minus 3 times 5 is a negative 15, and you add down, and you get 0. Okay, so we ended up with a remainder of 0. So if we want to make this back into an equation, we have to put our x's back into it. So I always work backwards. So I always say this guy is a no x, this guy is an x, and this guy is an x squared. Okay, and if there was more values, then you would just keep going down. Okay, so a no x, an x, and an x squared. Okay, and the last thing we're talking about is remainder theorem. Remainder theorem is the easiest because we take the opposite value, so whatever our 0 would be in this situation. So if x plus 4, we're taking minus 4, and all you're doing is putting it in for every x in the equation. So you're just direct subbing it